In this experiment, I recorded a constant velocity motion of a battery rolling across my desk. And the physics principles that were applied were Newton's second law, V final equals V initial plus F net divided by mass times delta T. And because in this experiment F net was 0, that would make it so V final equals V initial plus 0 divided by mass times delta T, which meant that V final equals V initial. And another equation that I used in order to determine the position of the battery was displacement final equals displacement initial plus velocity times delta T. I chose the battery as the system, which meant that everything else was considered the surroundings. F net was 0 because I assumed that the normal force would negate the gravitational force and that there was no friction. Here is the video on tracker. As you can see, I chose the right as the positive x direction because the battery was moving in the right. And we can ignore the y and the z because the motion is only in one dimension. Here, you can see the graph, and it's relatively straight, but if you look closely, there is a slight curve. We will mention that later when we look at the comparison of the experimental versus the model code. And here is the table of the time and position recorded. Now let's look at some key points in the code. Here I set the mass of the battery to be 0.015 kilograms, but it doesn't really matter because the force is 0. And the initial position I set as 0.001, which matches the initial tracker position here. And I set the velocity to be 0.21, which I calculated using the first few points of the data. And time equals 0 to begin with. Here is the while loop in which the code runs. The final time I set as 0.833, which matches the time here. And since this is constant velocity motion, F net equals 0. And here you can see the equation for the second law, and here you can see the equation for the final displacement. Now let's run the code and see what happens. You can see the graph here. Now let's compare this model created by the code to the experimental data we had on tracker. The model is in red and the experiment is in blue dots. As you can see, for the first few points, the model describes the experimental data very accurately. But, as I said before, the experimental data starts to curve and slow down. I think this is because we did not account for friction in the model, but in the experimental in real life, there was friction between the table and the battery, and so the battery slowed down over time. Because the code does not account for friction, there is a slight error at the end of the graph. Overall, I think that the model represented the experimental okay. It could have been improved if instead of a battery I used something that had more rolling potential, maybe like a ping pong ball, and so there would be less friction to represent an ideal situation more closely.